So in today's video we're going to be looking at the theory of continental drift or Pangea. They all kind of fit together. Continental drift, Pangea, and plate tectonics all kind of work together. And so we're going to see how this kind of began and developed over time. Okay, so Alfred Wegener was this guy from Germany. He was a German scientist who lived in the early 1900s. Now Alfred came up with the idea of plate tectonics or continental drift. Basically, he assumed that the continents were moving around from one another and were once one supercontinent. Now, it was quickly rejected by other scientists. Now, it was quickly rejected because his whole idea about this concept of Pangea, and Pangea is essentially the idea that the continents were all once connected in a supercontinent. Well, he thought that the continents were basically moving around like ships through an ice, like icebreaker ships. And so he thought that all these continents were just basically barreling through the land masses, and that's why it was rejected. Now, essentially, these ships could do this, whereas the Titanic could not. Of course, had the Titanic been an icebreaker ship, it wouldn't have broken apart in the middle of the Atlantic Ocean by hitting an iceberg, which is now found on the bottom of the sea. Okay, so Alfred Wegener's main theory about the fact that continents were basically moving, and they were moving at such a rate that they could actually go through land and basically break apart other land masses was basically thrown out, as well as the fact that his original theory showed that these drifting continents were moving at a much faster rate than what was being measured. However, once we were able to look below the ocean surface and notice some areas of continental ridges or mid-oceanic ridges were being formed, we could see that the plates were actually being pushed apart and new material and new crust was being exposed and made on the bottom of the ocean floor. It gave people more evidence to look at in regard to his theory, which basically solidified in the science community the idea of plate tectonics and continental drift. Okay, this whole idea about Pangea being a supercontinent really relates almost to a childhood puzzle. And if you notice how all these pieces kind of fit together snugly, well, if we dump them out and we look at them, then essentially you have different pieces that seem to fit together pretty well. And so if basically the desktop was made of some sort of fluid, these things would start moving around because the fluid is moving. Now, why would the fluid move in the center of the earth in the first place? Well, essentially the fluid in the middle of the earth is liquid magma. Essentially, if we could pull the plates back from the surface of the earth and see the magma below, we would notice that the magma, as it gets closer to the core of the earth, heats up and begins to rise. Then it starts to cool down and it falls back towards the core again. Once again, it heats up and it creates these convection currents that spin in a circle, basically giving some motion to the magma underneath the plate's crusts. Actually, what we are left with are these different plates that make up the Earth's surface. And these different plates essentially are moving around. Much like if you imagine a baby in a bathtub playing with his toys. We often see this in the little duck trials, when you see the little ducks floating in the water and you pull one up and see if your number matches. Those little ducks are floating on water. Or essentially if you think of boats floating around on a lake or an ocean. Essentially this is the idea behind the idea of plate tectonics. And as these plates are moving across the mantle, then they are going to obviously have times where they collide together, or they pull apart or do some different things. When these plates collide together, basically this is when mountains are formed, and we call this collision process where they come together, we call that a convergent boundary. Now, whenever plates move apart, we tend to see this more under the ocean at the mid-oceanic ridges, and we call that a divergent boundary. Now, divergent boundaries allow magma to seep up underneath the ocean and create new crust that spreads apart, which is the part essentially that got more scientists on board with what Wegener was initially proposing. Once that was determined, then it became more of a theory people could buy into and understand. Now, we also have a famous fault line in America that's right there in California where the two plates are doing this, going side by side. Now, that side-by-side action is called a transform boundary. Now, transform boundaries generate earthquakes where you have massive devastation and loss of life and property. So that tends to happen in a transform boundary. Now, there's also the type of boundary where the oceanic crust, which sits lower than the continental crust, is filled with water on top. And so all that extra mass of water, and then of course all that saturation of the crust, tends to cause that oceanic crust to fall below the continental crust. We call that subduction. Now in these subduction zones, this is where you're going to see volcanoes and things of that nature. Now volcanoes tend to be a lot around that main plate, that Pacific plate that's sitting out there that goes along Japan and other parts of that area right there. That's why we see so many volcanoes. Now this volcanic activity around this area where it's highly concentrated is called the Ring of Fire. Now I don't want you to get the Ring of Fire mixed up with Johnny Cash, who sang the Ring of Fire, or even Finding Nemo, where Nemo was expected to swim to the Ring of Fire to be a part of the group in the aquarium. The Ring of Fire essentially is the ring of volcanoes that surrounds the plate where all this activity is taking place. Finally, one last little detail about Wegener's proposal about continental drift that essentially gave more credibility to his theory later as we started looking at plate tectonics, was that he discovered that there were fossils that were found on continents that initially, in his theory, connected to one another, where you would find, for example, a Tyrannosaurus rex fossil on one continent that was separated by a major ocean, and you would find that same fossil of that organism on another continent. And the thing is that one of those continents might be in a very Arctic area today that would not have supported the lifestyle of that particular animal or plant organism. And so it had to be in a more tropical environment. So it led to the theory that the continent must have shifted from its original location hundreds or thousands of miles away. And so by having these fossil evidences on different continents that are now separated by large bodies of water such as the oceans, gave more credibility to the theory. Okay, I hope you enjoyed this video. If you have any trouble with any of this detail, please see me in class. Feel free to post me an email or a comment on my YouTube video. Also, my YouTube videos can be accessed by going to my YouTube channel. I hope you will visit it. Simply just go to YouTube search bar and just type in HPISD Hayes, Hayes, or click on my username that's below this video on the comment line, and it will take you straight to my channel, in which case you can see the other multiple videos I've recorded there. Anyway, see me in class if you're having trouble, or like I said, just post me a note.